All right, Blake, if you're listening to this recording, we're just continuing with chapter 8G, which is the quotient rule. And since this is nothing that new, I'll just record only my explanations. If there's any extra things, I'll mention. Otherwise, just work on the questions that I highlight here in the recording. And you can pause the recording to work on it if you need to. So you guys will only need to work on the ones that I highlight, which includes 1D, 1D, 1G, F and G. I'll walk through 1C as well. Okay, my plan is to go through 3 chapters today. So Charlie, if the moment I finish writing my answers for these questions, we'll just move on first, okay? Well, that's if I can do it faster than you. But if you get it done faster than me, then let's just move on. Hey Sarah, how are you? That's good. All right, here's your sheet, AG quotient rule. We're getting started with quotient rule. So you don't need to do the questions that I highlighted here, which is 1CD, F and G. And when I finish all my explanation for these questions, we'll have to move on to the next one.
G.
Mm.
If I have like
Mm-hmm.
my two parts, how do I like simplify it down?
So note that, yeah, okay, good question. Note that when you expand this, you get like some sort of x cubed, right? And then, x squared and x. Wait, hang on. There should be a bracket around these two. Yeah, you're multiplying the whole thing into. Yeah, same with that one there. So you see when you expand both of these brackets, there will be an x cube here, there will be an x cube here, which means you can combine them.
Yeah.
So that's a hint.
Do I times 6x by like 6x times x squared and then 6x times x as well?
Yep, that's right. And then same with the 2. Any questions, Sarah, on 1C?
Can you scroll up slightly?
Which part of 1C do you want me to go through?
Like I don't know how you got. I think I just did in a different order.
Mm-hmm. Which one?
The like first line, so I got confused.
This one?
Yeah.
Yeah. So remember, it's always u dash, v, and then minus uv dash. You always derive u first. Yeah, it will always have to be in that order. Oh, are you done already? G and H?
I haven't done H.
Wait, did I highlight H? No. So you can move on to question 2. I'll tell you which one I want you guys to do for question 2. Question 2 would be C, D, and E. 2 C, D, E. And then we'll see, Sarah?
I'm getting confused. You said it times two to the bottom and top. For what reason?
For what reason? Because I want to get rid of the 1/2 here. Yeah, when I times it in, the 1/2 is gone, and then there'll be 2 over here and then 2 at the bottom. The reason why I want to get rid of it is because I don't want like fraction in a fraction. When you see fraction in a fraction, you want to get rid of one fraction one way or another. So that's why I also keep the x power -1/2 as the -1/2, not become 1 over square root x, because then that's a fraction in a fraction. So Sarah, when you're done with C, just move on to F.
For question 2C, once you've like got the two parts, can you take out 2x plus 1 to the power of a half or not, because the other one will be negative a half?
No, so remember that one, that's the one where you have to change -1/2 into 1 over square root, and then you combine so one will be a fraction, one will be a non-fraction. You have to combine the two.
And then with the times by a half, do I just make it so it's just x squared?
Yeah, that's right, yeah. Are you on F, Sarah? Okay, finished? Or
Do you just expand to get 4x?
yes, because this is just -1 minus 1 is -2, and then times the 2 at the front. Yeah, 1G is long. C. G, right? Yeah, that's long. So note that in terms of notation, you need to at least write d over dx equals. Yeah, so like the derivative equals. And then that should be equal. Mhm. All right, moving on to question 2. So Sarah, just move on to question 2 first. 1G is just a lot of like algebra, that's really long. So I'll have the answer here, you can continue that later, leave some space for that, move on to 2C.
Was it C, D, E?
Yeah, C, D, and E. So in order for question 2, they're trying to differentiate between y coordinate and the gradient. So y coordinate is subbing to the original equation, and gradient is the sub x into the derivative. Yeah, that's the main concept of question 2. Done? Very good. Take a short break. And I'll tell you which one to do for question. Wait. We're skipping question 3. Not doing question 3. And we're doing all of question 4. So this is on the other side.
When you
Mm.
have like the whole either pair of x outside a bracket, does it just is it like 4x?
Yeah.
Okay.
Are you done with 2C, Sarah?
If they have the same power, like e4x, and would that become negative 2e4?
Yeah, that's right.
You can't simplify 4b more than like this, right?
Let's see. No, I don't think you can. Sin x. Yeah, I don't think you can.
It has it just written that you take the negative out.
Yeah, you don't need to take a negative out. This is just nice to have, but you don't need to. In the exam, if they want something specific like that, they will mention something like make the coefficient of sine and cos positive. Then yeah, you have to do that, but it's very rare. Okay, that's question 2. Next will be question 4. Sarah, where are you up to? 2e, starting 2e?
Yeah.
Okay, you can skip 2e for now, move on to question 4 first. Because if you can do 2d, then 2e is quite similar. It's just another quotient rule. So move on to question 4 first. For ABC, we're doing all of ABC. My goal is to provide you guys with as many example working out as possible. So if you want to, you can go back and work through the question that you didn't get to in your own time.
How do you do 2c?
2c?
I haven't done like the bottom line of it, but
Sounds about right. It looks about right, yeah. So when you multiply the 1/2 x into here, it will cancel out with the first term, but the second term it doesn't cancel
Yeah,
out.
so
So it'll just be
1 plus 1 over x minus ln x. And
Yeah.
Is that just over x plus 1 squared?
yeah. You can't do much more than that. Pretty sure. Yeah. They times x top and bottom to get rid of the fraction. But I think that is an optional. It's an optional step. But yeah, try. Just times x top and bottom. You done, Charlie?
Yeah.
Okay, good. Let's see. Charlie, it will be question 7 next. We're skipping 5 and 6. Do all of 7.
Okay. Does this become sine of 2x squared?
No, because sine x itself is one function.
Yeah. So is it plus 2x sine x?
Yes, that's right. yeah, let's just combine these two like terms. Okay, and yeah, okay, just finish for A, B, and C. Just do for A, B, and C, and then you can move on to question 7, sorry. I'll start on 7. Do you guys know what was the last chapter you guys learned at school? Do you remember?
I don't know, something stupid.
I think it's like 22, because that's to do with probability.
Yeah.
Probability?
Yeah, it was like chapter 22.
Yeah, my teacher said it was in preparation for Unit 4.
Yeah, but you forget it by the time. Okay, that's fine. You guys will be ahead for Unit 3, like I think a whole month ahead of Unit 3 when school starts. Sort of, I think, because I think they'll most likely start with chapter 6. I'm skipping chapter 6 because I'll let you guys do that at school first, and then once you are close to finishing, then I'll just go through the hard parts. So that's why I'm doing 8 first, because at school they will do 6 and then 8, and then the antiderivatives.
How do I do it where it's like a full bracket times that?
You don't need to expand it. So note that for question 7, they ask you to find f dash pi, which means you ultimately have to sub pi in anyway.
Okay.
So sometimes you can get away with not simplifying it, and then when you sub it in, it's just it could be a little bit longer. But if simplifying is too difficult, then just sub it in. Sarah, let me know if you need any need to see my explanation for the previous questions, yeah? But I think they should be okay.
If it's cos x times x, it's x cos x, right?
Yeah. Okay, very good. See if you can do question 8. Okay, the proof one. It requires some interesting manipulations. See if you can work that one out. It's a complex familiar. Last question for this chapter. Okay, which one are you up to now, Sam? 7C? Okay. And this is the sheet for next chapter. Some application questions. Not yet actually. Tangents and novels. Did you get it? Okay. Alright guys, I will pause you guys here. I'll walk through this one question and then we'll move on to the next chapter for a bit. Okay. Alright, so in this one, again, when you see a quotient rule, you just apply the quotient rule. So I'll quickly do that one first. So f dash, right, would be u dash. So this is u, this is v. So u dash would be cos x, u dash times v. So cos x times cos x. And then minus u, which is sin x. And then v dash, which is negative sin x. Right, over v squared, which is cos x everything squared. Right, simplifying this would get me cos x everything squared, right? And then plus sine x everything squared over cos x everything squared. Now the actual answer will come in 2 lines, and there are 2 things that you need to remember. So the first thing is cos x everything squared is the same as cos squared of x. That's it, right? And then Sarah, you might remember this from specialist, but it's the one of the Pythagorean identities or something. So sine squared x plus, right, cos squared x equals to 1. This is just an identity that you need to remember. Okay, the proof of that is quite simple. If you have, like, let's say hypotenuse, and this is the angle x, that's the let's say A and B, right? And then hypotenuse is C. So sine x would be B over C, right? And then cos x is A over C. Okay, if you go sine squared x plus cos squared of x, you would get A squared over C squared plus, sorry, B squared over C squared plus A squared over C squared. So this is and this is the right angled triangle, which means that the top, right, is just A squared plus B squared over C squared. And what is this? In the right angled triangle, this is the same as the hypotenuse square, right? Which is why this is equals to 1. So sine squared plus cos squared equals to 1. Right? That's just a very quick proof of that. And if you recognize that, that means you see that this is the same as the top would be just sine squared x plus cos squared x over, right, cos squared x, and that would just be 1 over cos squared x, and that would be equals to the so equals to the right hand side, and then brackets shown. So technically I should have started off with left hand side equals to this. Okay, so the proof structure is normally left hand side equals to something, and then everything, and then at the end equals to the right hand side. So you show the left hand side, which is that, equals to the right hand side, which is that, and then you can say it is shown. Okay, and just gotta show the algebra steps in between. But yeah, that's it. You just rely on 2 new concepts, well, not that new, but 2 concepts that you guys might have forgotten, and that is it for this chapter. And we'll put it aside, and then we'll start on chapter 8G. Now 8G, tangent and normal. Do you guys remember the equation? Well, did you guys get to learn the equation of the normal in unit 2 and 3?
Not really.
Not really. Sarah?
I think so.
No? Okay. Well, then you don't need to. Yeah, when you see the equation of the normal, you can just safely skip it, I think. Yeah, just safely just skip it. I'll tell you guys which one to do. Don't need to do all of these questions here. Let me see. Alright, we're skipping everything. We go straight to question 9. So this is chapter 8. H? Yeah. So we'll start off with question 9 first, because that's the new stuff. I think all the easier bits you guys already know how to do, right? Sarah, what's the equation of the tangent? What's the formula for that? Charlie?
Y minus y1 equals m times x minus x1.
Yes, that is correct. Okay, so the equation of the tangent is just this. So equation of the tangent line is y minus y1 equals to m, which is the gradient, and then x minus x1. Sarah, what's x1 and y1?
Given point.
The given point, correct. Yeah. If you have a graph like that, the tangent goes through a point. The coordinate of that point is x1, y1. Okay, so for this question, just do C and D. Yeah, not C, not D. You don't need to do A and B. I think it's too easy for you guys.
Well, what are we supposed to do? Like, we've never done this before, so
Oh, really?
Yeah.
Okay, I'll show you 9A then. So have a look. I'll show you 9A and then you can do C and D. So question A. You just need to, you already got the point x equals to 0, right? Which means you need the, so this is the idea for question 9. So you need the, so you have x1 equals to 0, right? That's x coordinate of the point. You need the y coordinate y1, right? And also need the gradient m. Okay, and the gradient is essentially just deriving it, so that's y dash at the x value, which is 0. Okay, and y1 is essentially sub-zero into the original equation. So this is basically similar to the question that you guys did in the previous chapter, where they asked you for find y coordinate and find the gradient, right? So this question just has one more step, is to write the equation of the tangent. That's it. So you find y coordinate, find gradient, and then sub into the equation of the tangent formula, which is this one here. Rearrange that to get that. So normally you want in the form of y equals to mx plus c. Okay, so you start with this one, and then you need to manipulate to get y equals mx plus c, and that's it.
But for A, when you derive it, it would become cos of 2x.
2 cos 2x. Okay, so first y coordinate y at 0 would be sine of 0, 2 times 0 is 0, and sine 0 is just 0, and then you derive that. So y dash. Now sine becomes cos, right? But then there's an inner function which is 2x. So you gotta derive that, which means you times it by 2. So that's why it's 2 cos of 2x. So then y dash at the point. So this is the m value. Okay, this is the m, and this is the y1 value. So the gradient m is just 2. So that'll be
sine of 0 1?
Sine 0 is 0.
I thought it was 1.
It is 0.
When it's in the middle, that's the 0. So then if it's sine of 0, it wouldn't.
Not quite. It's a point on the right.
Why is that 0?
Because 0 degrees means, so the angle always starts from the positive x-axis, right? 0 degree means you move nowhere. The middle point is pi on 2, 90 degrees. Yeah, the middle point on the top, this one is pi on 2 because it moved that line by 90 degrees. So it's pi on 2. So 0 means you don't move that line at all. So it's just the point on the right hand side, and that coordinate is cos is 1, sine is 0. So cos is 1 and sine is 0. So that's why this one would be cos of 0 times 2. So that will be 1 times 2, which is 2. So we've got the m value is 2 and y1 is 0, which means the tangent, right? The tangent would be y minus y1, which is 0, equals to the gradient 2 times x minus x1, which is 0. So simplify, y equals 2x. Done. Any questions, Sarah?
No.
Now, then try question C.
Why do you have negative x?
Negative x?
Yeah.
Because the gradient is negative 1. Did you get gradient negative 1? What's your gradient?
I got 1.
Cos pi is negative 1.
Oh, yeah.
Yeah, and I will change it. Any questions, Sarah?
Like the plus cos x when you derive it is from which like original things that
Which one? This one?
yeah.
Yeah, so I'm deriving the sine x, so I get cos x. Right, there are 2 terms, so you need to derive those terms separately. Did you use the product rule?
Yeah.
Yes, okay, I thought so. So this one, when you see that, right, because it's separated by a plus, that means it's this thing as one term and this thing as one term. Now, a product rule would look something like this. It would be cos 2x sine x, right? That means it's multiplied. If you see multiplication of 2 functions, that's the product rule. If it's a plus, that's just 2 terms. So if it's 2 terms, you just derive each term separately.
When you're deriving 9d, would your second part become 2 cos 2x? Because the front x wouldn't derive, it would just become 1.
Yes, that's the first part. Then you need the other part of the product rule because that's a product rule. The second term is a product rule when you're deriving it.
Of course not. Would that be my...
Yeah, that's right.
Okay.
Ninety has a very nice tangent. Alright, if you're done with 9 CD, just move on to 10 AB and 11A. Let me just do the starting questions only. Okay, so once we finish 10 AB and 11A, we'll take a short break. Any question, Sarah?
What is the gradient again? How do you find the gradient?
The gradient is literally the meaning of the derivative. The derivative, when you evaluate at a point, it is the gradient.
How did you put that into the equation?
The equation is what? So it's y minus y1 equals to the gradient times x minus x1.
Is the gradient the derivative? Wouldn't that mean you substitute? Was the gradient just what they ask you to like substitute? Because it says pi, and you use pi to find.
Pi is the x value. Okay, I'll give you a visualization. So see, remember this one there, right? So if you have a graph, let's say it looks something like that. This is a sine and cos graph. Okay, let's say this is the point here. So they're saying at the point where x equals pi, right? So on the x-axis, it's equals to pi. What's the equation of the tangent at this point, right? So the gradient of the tangent is the instantaneous rate of change at that point. Is the gradient at that point, yeah? So the gradient of this tangent would just be so this tangent will be y equals to mx plus c, right? But it's the gradient times x plus c. So the gradient of this one is essentially the same as this gradient here. And that is just y dash at the x1 coordinate. So you calculate that and then you put that into the formula here. Yeah, does it make sense? Yeah, so the x value, so the given x value is only the x coordinate of the point. So you need two more information. You need the y coordinate and the gradient at that point. And the gradient at that point is when you will derive it, right? When you will derive it, and then you substitute the x into the derivative in order to get the gradient.
Which question for 11 are we doing?
Just 11a. Well, you just can do B as well, but yeah, 11a is the one. What question are you on now, Sarah?
9D.
9D, okay.
When you have the ln ones,
Mhm.
that term, when you like derive it, what's like the process to derive it?
ln x just becomes 1 over x.
No, I know that, but if it was like ln of like 2x,
Then you derive the inner function times back in, so it will be,
it'd be 2 over 2.
yes.
And for question B, because they already gave us like both coordinates,
Yep.
we don't have to work out.
That's right. Alright, did you get that? Good. Alright, if you're done, then you can take a short break, Charlie. So, Sarah, are you on to question 10? Or just 90 still?
Yeah.
Which part?
I think I just need to put it together.
Oh, okay. So you got the gradient, which is 1, and the y coordinate, which is 0. Right? Yeah. And put together into the tangent and resolve that. And yes, you will need to do question 10AB and 11AB first. Okay? So that will eat into a bit of your break, but yeah, you have to get those ones done. Yeah, I'll stop the first half of the recording now.